0 degrees.
It's good enough.
Except I can't see that. No, do it in the back.
Okay, like this.
Yeah, I think that's the best of all options.
What is the problem with the...
Yeah, but for Reba, it's relative to the vertical. This is 0 degrees.
Heavens. Heavens.
This is 90 degrees, and this is 180 degrees. Okay. So when we're doing, I mean, you're looking at HAT. You're taking two segments. Two data points. This is the x1, y1, x2, y2, x3, y3, x4, y4. And when you do when you get the angle for the head and trunk, you find this angle, right?
Yes.
Yep.
That's theta. What did we call it? Theta 3. Okay. Theta 3 is relative to the horizontal. Well, we need something that's relative to the vertical. So what you're going to have to do is take your theta 3, and if it's in this quadrant, you'll have to subtract it from 90, because what you want really
45?
is that angle, alpha. Okay.
You mean 45 degree?
From 90.
Oh, 90.
90. What did I say?
You said 90.
I
yeah.
said 90.
I
Yeah.
thought
It's
it was gonna
subtract
divide
from
it.
90. Because what you'll be interested in is alpha, the angle relative to the vertical. Right, does that make sense?
Well, for the trunk, yes.
Yeah, for the trunk. Now, let's look at some of the other ones.
Yes.
That's just the trunk.
Yeah.
This one, you can't measure. You have to just judge based on your video. This one's a little more tricky. Okay, so let's take a closer look at that one. And also for the head, I don't think anybody's doing anything odd with your head. You can just call that a 1. I mean, unless you're swinging your head around while you're lifting the box, which I haven't seen anybody do on the video yet. So I think that's going to be a 1. Okay, so this is the angle between the thigh segment and the lower leg segment. Okay, that's the angle that we're looking for there. So you have, here's the hip, knee, and ankle. So for the hip, and it's been a while, I believe that you get that angle. If you do our method, okay? And at the ankle, you get that angle. So that would be theta 4, theta 5. Verify what you get before you do that, but I believe that that's what you'll end up with. Okay. And what we're interested in is this angle, alpha. Okay. So to get this, I'll call this alpha 1 and alpha 2. To get alpha 1, that's going to be equal to 180 minus theta 4. And to get alpha 2, that's going to be equal to this. If this is theta 5, that means that this is theta 5 here. So alpha 2 will be equal to theta 5.
Minus.
No, it should be
the opposite.
It should be the opposite.
Yeah, yeah,
so
okay,
it's just theta 5. That means that then alpha will be equal to 180 minus theta 4
Plus alpha 5.
Theta 5.
Theta 5.
Okay. So far, so good?
Yeah.
So that one, like I said, you have to think about that one a little bit, but that should work out that way. Sorry? Oh. I'll move over here to the side. So that's the part for HAT is pretty straightforward. This is a little bit trickier, but not too much. I just have to use some different angles. And I'll leave that up there. I'll do another one over to the side. Now let's look at the upper arm. the upper arm, 0 is straight down, I believe.
Yeah.
Yes, upper arm 0 is straight down. So, what we're going to want is relative to the vertical again, except now 0 is here and 180 degrees is up here. Okay? And we'll be looking at the elbow to shoulder angle. So if this is shoulder and this one is elbow, so this is x2, y2, and this is x3, y3. I can calculate, one thing I can do is calculate the shoulder angle, okay? Calculate shoulder angle, and that will give me this, theta 2, right?
So the upper arm? Sorry?
I'm sorry?
The upper arm, right? We're doing the upper arm or the
we're doing upper arm, yes.
upper arm?
Yeah, yes, sorry. So if that's theta 2, and I want it relative to this, if I'm in this quadrant, this alpha will be equal to 90 minus theta 2. It's just a complement of it.
Yeah.
If it's up in this quadrant, then it would be 180 minus theta 2. Depends on where I am.
Yes.
If I'm here, it's 90 minus. If I'm up here, it's 180 minus, because I have to get this. I have to get a larger angle. So far, so good.
Yes.
I think so.
Okay. Then for the lower arm, this is also relative to this. So for the lower arm, it's straight down is 0 degrees, straight up is 180 degrees. So if this is the elbow, x2, y2, and then this is the wrist, x1, y1, that gives you theta 1 right there. However, what we want is alpha. So again, that's 90 minus theta 1. Unless it's up in that quadrant, then up here, it's 180 minus theta 1.
Can we do 90 plus?
Actually, I take that back, because that's the negative quadrant. If you apply this without thinking, since that's negative up there, you can still use 90 minus theta 2. And since that's negative up there, you can still use 90 minus theta 1. You don't need this. Because if you just leave the angle that it gives you. Okay, what was your question?
I said, can we do 90 plus?
If it's actually no, because if it's down in this quadrant, this is the positive quadrant, and you'll get 90 minus theta 1. Up here is the negative quadrant, and so you'll have a negative number, and 90 minus plus, it'll add 90, it'll add a 290 for that part up there. And then for the wrist, again, just you can't do that. You have to just estimate it from the video. And once again, you're just holding it straight, so I'm going to guess that that's probably a 1 for all of you. Does that help? Yes? Kind of, sort of. Any other questions about the project before I finish this topic? Yes.
In the tables, when we look at the percentages of population, which one should we use?
Give me a range, since I didn't specify. That's what I'd do. Okay, so everybody is comfortable applying NIOSH, GARD, REBA, and the psychophysical tables.
Question,
Yes.
for narrative, what unit do we use for the measurement? Is it
You can,
meters, centimeters?
You can use whatever units you feel most comfortable with. However, you can either use the metric equations, because there's a different set of equations for metric and a different set of equations for US customary. If you use the metric, I believe it assumes centimeters and kilograms. I believe.
Centimeters?
Rather than going from my faulty memory, let's take a look at it. Okay. Centimeters for length, and vertical height, distance, it's all centimeters. That's the same for both because it's angle. Degrees, we'll expect. Frequency, that once again doesn't matter because this is for centimeters, or V is in inches, but you can do it for centimeters also.
V is in inches?
Yeah, for this, because this table happens to have V in inches, but you can just convert it, doesn't matter if you're using centimeters.
Okay.
You probably aren't going to have a problem with it. So what did I say, 4 per minute? Okay. If it's less than 1 hour, doesn't matter. If it's greater than 1 but less than 2, it doesn't matter. And if it's greater than 2 but less than 8, it doesn't matter. So your frequency multiplier is the same, regardless of vertical height, for 4 lifts per minute. And somebody, I forget who it was, somebody came in, they were a little confused about this. You have to measure height in either inches or centimeters, vertical distance in either inches or centimeters, and distance in either inches or centimeters. And then to get the multiplier, you have to put those values into those equations. Because you can't just measure it and stick it right into the equation. You have to convert it into a multiplier using those measurements.
But the tables are already done?
The tables, if you want to use the table, for this, for instance, if you want to use the table, you can.
But that's where the limits come into effect.
Yeah, what's in here is the multiplier.
Yes.
Yes. You don't have to put it into the equation. I find that a little bit cumbersome, but if you want to use that, yes, you can.
Okay.
That's the multiplier already in there. And you'll notice the multiplier is never greater than 1. This is a proportion. Because what we're doing is we're cutting down this original load, the load constant. It's either 51 pounds or 23 kilograms. That's pretty much the limit. And what we're doing is saying how close we are to that limit for lifting. You know, it discounts it. If it has something, the further that you lift, the further the horizontal is, the more it cuts off the 23 kilograms. The further the vertical, the more it cuts off the 23 kilograms. That's why these multipliers are all between 1 and 0, because it discounts. It progressively discounts the amount of this load constant.
So,
zero,
sorry.
Go ahead.
So on the tables that have the multiplier in there, I'm still a little confused here. When you hit that limit, if you're greater than that limit, that's when you have to do the equation to find what you have.
Yes.
Okay.
Yes.
All right.
Yeah.
Thank you. Sorry.
Yeah, that's okay. That's okay. I don't want to say what I was going to say anyway. I'm glad you interrupted. Teaches me to keep my mouth shut. Okay. Other questions about the project? Due in 2 weeks. You get a break from me again next week. So that'll be good. For this project, all you need to send me is your PDF of your report. I already have all the source data, so you don't have to worry about all that. Just email me the PDF of your report, and then print it out and bring it to class, and give it to me at the beginning of class in 2 weeks. Okay. Any other questions about the project? I will be around. Tomorrow I'm giving exams all afternoon, but you can catch me in between. Friday I'll be around in the afternoon for a little bit if you have questions. Monday I won't be in. I have some commitment in the afternoon, but I will be in Tuesday afternoon. If anybody's around next week, I expect this to be wide open spaces, but if anybody happens to be around, it will be in on Tuesday afternoon, then I won't be on the Wednesday. And so if you need to catch me Friday or Tuesday afternoon is your best bet. Okay. All right, in that case, let's go back and talk about the things that I haven't talked about yet. I skipped a quick exposure checklist, RULA, and the strain index. So we'll talk about those three before going on to the next and last topic. Quick exposure checklist is a good first cut. And that's why I originally had it first there, but we were a little bit pressed for time, so I thought that I'd skip it. But this is the first cut, and these are some good the references on it. One thing that is nice about it is that it includes psychosocial factors, which aren't normally included. Okay? These are things that the authors say that it's good for. It is good because it includes a lot of different factors, and it's not good because it includes a lot of different factors. It's kind of diffuse, okay? So that's why I always say that it's good to use this to evaluate your jobs initially. Before you do anything else, it might be a good idea to do a quick exposure checklist, because as the name implies, it's pretty easy to use. The disadvantage is that you have to choose a worker to assist with it, because it has some worker evaluations included in it. That's why it has that psychosocial component. It has pretty good inter-observer reliability. More than one person does it, they get about the same results. Okay? Not great with it, but pretty good. And it has been shown to have high intra-observer reliability. Okay? So if you do it multiple times, you'll get pretty much the same thing, which I hope is usually the case, but you can't always count on it. So intra-observer is the same person doing it over. Inter-observer is different people using it. The quick exposure checklist looks at the back, shoulder, arm, wrist, hand, and neck. And in this case, the capital letters are the safety professional or the ergonomist or whoever is doing the evaluation. And they go through here and they circle each one of these. Now let's look at each one of those questions in turn. I'm going to try this. First one is back posture. Is it almost neutral, moderately flexed or side bent, excessively flexed or side bent? These are the definitions of what is almost neutral, moderate, and excessive. And if it fulfills any of these criteria for moderate or excessive, then you give it the appropriate score, A1, A2, or A3. Okay? And there are degrees associated with it, and it's typically not done from a video. So, or you could do it from a video, but most of the time it's just the observer's guess. Back movement is B1 through B5. Now, this you can measure easily. 3 times per minute or less, 8 times per minute, 12 times per minute or more is a B1, B2, or B3. And then you have to give it, is the task performed in static postures most of the time? If it's a no, you get a B4. If it's a yes, you get a B5. So you have to observe long enough to see whether or not it's predominantly, and it's not defined, but predominantly is, static posture. If you have non-manual material handling tasks, you ignore B1 and B3. So if you have a seated task like office work, you ignore B1 and B3 and you say, and you answer whether or not it's static or not. Then we go on to C, which is shoulder arm posture, at or below waist height, at or about chest height, at or above shoulder height. In other words, how high are you holding your hands or your arms habitually while doing the task? Okay, and you mark C1 or C3, 2 or 3 accordingly. Shoulder arm movement, and infrequently, frequently, and very frequently have somewhat operational definitions. Some arm movement, regular arm movement, almost continuous arm movement. So it's your judgment as to what constitutes those. They have some guidelines in the article about what constitutes frequent, infrequent, and very frequent. Right? And you have to use your judgment accordingly. Wrist-hand posture, almost straight, deviated wrist. Okay, E1, E2 is based on whether it's 15 degrees or more. Unless there is something unusual happening, usually it's a fairly neutral posture. Now, if they have a screwdriver and they're doing something like this to get it really bearing down on it, if it's obvious, you give them E2. Frequency of hand movement, self-explanatory. Give them an F1, 2, or 3. Neck, performing the task is the neck bent or twisted excessively. Okay? Now the rule of thumb is 20 degrees. Usually we're not doing this from a video and motion capture information or data, so you have to call whether or not it's occasional or a continuous deviation to the side or to the front. And if you're doing a task that almost always has your head bent like this or like this. Now, what does this remind you of? Telephone, right?
Yeah.
A telephone is a 3, okay? Because that's what people do. They sit there like this when they're talking on the telephone. Despite all of the technology and gadgets available, what does everybody do? This, okay? So, they get a G3. Okay, now, the little ones, I don't know whether this was on purpose or not, but the small letters are what the worker gets to answer. And this is where the psychosocial comes into it. The maximum height handled in the or weight handled in the task. Okay? How much time on the average you spend per day doing this task. Okay? They estimate that from performing this task. Single or double-handed was the maximum force level exerted by one hand. Okay? And they're going to have to guess this. This is very psychophysical, in addition to being psychosocial, because this, they might know, but they'll probably estimate. The time performed the task, they'll probably estimate it being more than it is. The weight exerted by one hand, they'll probably have to estimate that. Vibration, they might have a good idea of that, what constitutes vibration. Visual demand for the task, they should have a good idea of that. Do you have difficulty keeping up? Now this is nothing but psychosocial. Do you find it difficult to keep up with your work? And how stressful do you find this work? Right? Again, the last two, these have sort of a psychophysical or psychosocial component to them. These ones are definitely, these are purely psychosocial in nature. So you get your worker to fill out this form, supervised, and to make sure you get it back, and then you score it. Okay? And the way you score it is you have to get score 1, and this, what they're trying to do is make this compact. That's why it's as non-obvious as it is. So, let's go make some assumptions. Let's go back and let's make some assumptions. Okay, and I will just arbitrarily say that this one's an A2. Okay, this one it's rather arbitrary, but it'll show you how to score it. And it's a B1, and that there are no static postures, so that's a B4. And that the task is performed at waist height, nothing, no overhead work. and that it has a certain amount, frequency of arm work, so that's a D2. And that there isn't any deviation, so that's an E1. And that 10 times per minute or less, 11 to 20, we call that an F1. And the neck has no twisting, so that's a G1. And then the worker says, okay, it's light, it's moderate, I do it 2 to 4 times a day, G2. I don't have anything very heavy, so I call that a C1. No vibration, so I call that a D1. It's the visual demand. It's fine work, so I'll say it requires a lot of detailed work. However, I find it very difficult to keep up. F3, and I find this moderately stressful, so I call that a G3. Okay? So let's just assume that these are our results. Now, let's take those results and see what kind of a score we end up with. So, it's an A2, so let's circle A2. Matter of fact, let's go circle everything. A B1, B4, here. C1 is right here, and if I circle the wrong thing because I can't read it, let me know. And I'm doing capitals, so capital D2. E1 is the next one. Yes. E1, and then what's my F? F1 and G1. That's an F1. Is this a G or an F? I can't even read it from here.
I think that's an E.
That's an E.
That's
I
another
think so.
E1.
Oh, that's another E1. That's right. There's,
The one in the middle?
yeah. That's an E also, isn't it?
No, that's B, small B.
Oh, that's a
That's
small
a small
B.
B.
Okay.
Yeah, so the one even,
Another
the
G1.
middle, the third middle one is not an E.
This,
Up
that,
to the left, to the right, that's not an E.
oh, that's not.
No, even up, the one you,
Okay, F and E1. Oh, actually, that will. Thank you. Okay, so those are the A's. I got that. The big A's, the big B's. Got that. And B4 got that. C. Got that one. B.
E is,
Oh, this is a little b. Yeah. Thank you. You were trying. I just couldn't see. And then this is F. It's an F1. Here's another. Here's an E. That's an E1. And down here we have the G's. It's a G1. Okay. Now we'll do the little letters. That's an A2. B2. Another set of A's down here, so it's an A2 and a B2
there's a B2 on top as well.
and a B2 up here.
Below A2, small A2, there's A you put.
Yeah, so do we have to circle all the B2s on the table? Okay.
Yes.
That's
That's what we're trying to do.
It's ridiculous.
It's a real hunt and peck thing here. And, okay, so now we got little C's. It's a C1.
It's another
Yeah.
E2.
At least I'm being entertaining, right? B2.
Now, if anybody came up to me in the hangar and like was doing this, I would just laugh because I knew what they had to do after. You know, like
That's right. Okay, that's a B2. E, it's E2. Okay, did I find everything? Oh, then we got the F and G.
All the way to.
So here's a D. It's a D1, an F3, and a G3. 3 and G3. Okay, does it look like I got everything? Thank you. Okay, so what do we do for our scores? Find the intersections of everything. Actually, what I should do is I'll do those intersections in another color. Oh, I forgot this guy. What is that one? Is that a
B2.
B2?
Yeah, I think.
Those are independent scores. Now, actually, I need to borrow yours again. Never mind. Thank you. I'll use another color to add them up. So the first score, score 1, is
6.
this, which is a 6. Actually, that's probably easier, yeah. Why don't you just read them off to me? Okay,
4.
and this is a 4, and this is a
6.
6, and this
6.
6.
4.
Well, no, that one, do you have to have both?
Yeah,
It's 4 and 4.
yeah, 4 and 4, so that's an 8.
Okay.
And then the total score is 10, 16, 24, 30. Okay. So that's our total score for the back. I don't think I need to elaborate on that. You can see where we're going with it. What you end up with, well, what the heck? Read them off to me.
Well, what's it going to say? Some of the scores is 1 to 5.
It says sum of scores 1, 2, 5.
Yeah.
In other words, this is score 1, this is score 2, 3, 4, and 5. So
okay.
it scores.
I
Okay.
thought it's like the
No,
total.
it doesn't have to be one between 1 and 5.
Okay, gotcha.
Okay. So this one is a
4, 6, 6, 4, and 6.
and so that's 10, 16, 26. Okay, what's this?
2, 2, 4. And then 4 and 4.
Okay, so that looks like 8, 12, 16. And this one is
This one is 4, 6,
it's 10, and that's
1, 9,
18, 19. Okay. So this is we have a back score of 30. We have a shoulder score of 26. We have a wrist and hand score of 16. And a neck score of 10. And the bottom score, the worker's evaluation total is 9, and then what you end up doing is adding all of them together, and all of these scores together. So it's 30, 56, 76 minus 4 is 72, 82, and 19 is 101. Okay, so The total possible is 218, so this gives us a 101 over 218 times 100. And somebody do that for me, just out of curiosity. It looks like it's going to be slightly less than 50%, but give me
46.3.
46.3, close. 46.3%. And then what they assume is that you have some action levels based on that. So this looks like it's going to be in the investigate further. It's not acceptable because it's not less than or equal to 40%, but it's an investigate further. And also they have equivalent scores for RULA, which I find interesting, since these haven't been really validated anywhere, but they assume an equivalent score for RULA, which is the next one we'll be talking about, very similar to REBA. But again, if I were using this, I wouldn't just do one job and then say, oh, it's acceptable, I don't have to do anything else. I would look at all my jobs, and then I'd use this to place them in order of priority to do something about it. I don't think there's anything magical about 40%. If it's less than or equal to 40%, I don't have to do anything about it. But if I get a 41%, then I better go do something about it. I think that's ridiculous, but it does allow you to place them in order of priority based on the amount of stress. And like I said, what I like about these is that it does have a worker component to it. So it has that psychosocial component that allows you to incorporate how stressed the workers are, feel while doing it. So that's the benefit of it.
This one is coming to this?
I'm sorry?
This part is coming to this?
I won't actually have you do one of these, however, I might ask you about it.
This bigger question.
Yeah, a non-calculation question, let's put it that way. I might ask you about this, okay, but I won't. I mean, I would have to give you all these tables and then give you a hypothetical scenario. It would be very unwieldy, and I'm not sure how much good that would do you. Okay. But I could ask you about it. Okay. Questions? Quick exposure checklist. That's this part. That's the big one, not validated. It's good. It's pretty usable, pretty good sensitivity for detecting changes when they're actually there. It has sort of a base validity validation, but it hasn't been formally validated. All right, we talked about REBA. We can skip past REBA. Now let's look at RULA. Now, if you'll notice, RULA was created by the same people who brought you REBA. Right? They like four-letter acronyms that you can pronounce, actually, obviously. McTavish and Corlett, same guys, same people. Its upper limb is, however, it includes in it the entire body, because the assumption being that your upper limb activity and your upper limb strain is going to be influenced at least a little bit by the position of the rest of your body. So it does have the whole body, but it's meant to evaluate the upper limbs. However, fine finger movements it's not intended to do an analysis of fine finger movements. Something like typing or fine assembly, that sort of thing. This isn't appropriate for, but it is larger upper body movements. Uses all the risk factors, and it looks at musculoskeletal risk before, after, and comparison of other jobs or some of the best applications of these. Now, this should look pretty darn familiar. We have an arm score and a lower arm score. You add one if you have to cross the midline with one arm or the other. Have a wrist score, which is a little more detailed than the REBA wrist score. The wrist score is a flexion or extension and flexion, and 3 different possible scores. And it also has a score for ulnar radial deviation. Then if you'll look
at the bottom, there is a wrist twist score, which doesn't have an illustration associated with it. The wrist twist, it's always hard for me to say, is if it's mainly in the mid-range. In other words, this is supination pronation. Okay? If I'm just doing something within sort of the mid-range of that motion, that's a 1. Well, however, if I have to twist really hard or far, then it gets a 2. Screwdriver. Think of a screwdriver for number 2 for wrist twists. Then you put your score for the upper arm, lower arm, wrist, and wrist twist into these boxes, and you get a score according to this table. And that table is the same as the Reba table. Or it's not the same thing, but it's read in the same way as the Reba tables. So you locate your wrist posture score, your wrist twist score, and then your upper arm score and your lower arm score, and you read your score A off of that table. And you put it in this box. We'll come back, we'll talk about muscle and force and score C. Later. Then for neck, trunk, and legs, you use, this is the neck. Once again, it's a little bit more detailed than Reba. The trunk, somewhat more detailed again than Reba is. And then the legs. If the legs and feet are well supported, or evenly balanced, and 2, if that's not the case. So you take your neck, trunk, and leg score, place them here, read your score B out of that table in exactly the same way that you read Reba. And like I said, this was developed by the same people, so it's very similar. It's just that the part of the body that is emphasized in this analysis is the upper limbs rather than the entire body. Then for both of the muscle and force scores, you use these tables. If it's static, held for more than a minute, and if it's repeated motion, more than 4 times a minute. And so this is a 1 or a 0. If it meets either of those criteria, it gets a 1, otherwise it's a 0. For force, it's based on the amount of force that you estimate that is being exerted. No force or less than 2 kilograms intermittent, 2 to 10 intermittent, 2 to 10 static, or 2 to 10 repeated is 2, and then 10 kilograms or more, or if there's a shock or a force buildup, gets a 3. And that goes into both of those scores. Okay. And then you add those values together to get score C and score D. Score C and score D go into this table, and that's your grand score, and this is their action levels. They have 4 action levels, very similarly to Reba. Yes?
Would that, the force we were looking at before, would that be 200 load force or 100?
It depends on whether it's a one-handed or a two-handed task. And if it's a two-handed task, then it's two-handed, and you would have to evaluate each side differently. If the postures are the same and the force is the same, then you don't divide it. So you use the absolute value of the amount of force required. So if you lift a 10-pound box, that's 10 pounds. But if you have different postures on either side, then you'd have to run this part of it in 2 separate ways. You'd have to get a score. You'd end up with a grand score for the right side posture and a grand score for the left side posture, and use the one that's worse. Now this is an example. Again, I put this here for you to take a look at. But this kind of looks. This is a sort of a a hybrid whole body upper arm type of motion, reaching into a box to grab something. That's why Rula uses the entire body posture, because this individual really isn't using his entire body, and yet it's a standing activity, so you can't discount what goes on with the rest of the body. This is an evaluation of reaching into this box when sitting flat on the floor versus being given a ramp in order to reach into the box more easily. And here they have a great deal of detail of how they scored for the original position and for the redesign. And they claim a reduction from 7 for this, for everything, whereas as low as 1 if something's at the top of the box, or 4 if it's at the bottom of the box. Okay, but this ramp allows you to adjust the tilt so that you don't have to strain as much to get into the box. And I think this is a good illustration of the use of that. It's not a fine hand movement, but it is a primarily upper body movement. Okay, this I tossed in here because this is actually some studies that were done on the Rula scores. Okay, it doesn't have a lot of resolution to it, but it's better than what's been done with most of them. So let's look at the first table here, the neck score. All they did is a neck posture score of 1 or greater than 1. Like I said, that's not very good resolution, but it's better than what was done up until now. And then they divided into whether or not the person had pain or no pain. And there's a chi-squared, and you guys should remember chi-squared from QM. It's just a row total of a column total. Okay? In order to, and then from the observed, and they found that there was a significant difference. That there was more, the people who experienced pain were more likely to have a score greater than 1. And this is very similar to a case control type of approach. However, here the exposure is here, and the pain pain is the outcome. For trunk, found that there was no relationship, right? P of 0.48. For the upper arm, again, there was still a non-significant relationship. It's getting close. The p-value is 0.07, but still not 0.05. For lower arm, there is a significant relationship. So neck and lower arm, we appear to have a significant relationship. However, for trunk, upper arm, and wrist, there isn't. I mean, that's not very convincing. Okay, but at least they did some sort of validation study with it. Here, they took not just the individual scores, they took score A and score B. None of them, as far as I know, looked at the grand score, interestingly enough. But they looked at score A and score B and found that there was a significant relationship between, if you have pain, you're more likely to score greater than 1, significantly so, and you're more likely to have a score B greater than 1 if you are exhibiting pain. Okay. So these are kind of fair to middling results. This implies that the individual body part scores aren't very good, but the summary scores are probably better, which is an interesting result. This may be driven by the fact that you have these subparts that do show some significant relationship. Okay, questions so far? Talked about QEC and Rula and some of the validations work that has been done with Rula. Let's look at the strain index. The strain index is a method of scoring work with the distal upper extremities. This is something like typing or fine work with your fingers. That's why I tossed it in there. And they have 6 different risk factors. Okay? Intensity, duration, effects per minute, hand, wrist posture, speed of work, and duration of tasks per day. And then a score associated with it. It's kind of a convoluted method. But let's take a look at each one of the components. Intensity is light effort, and MVC is maximum voluntary contraction. To actually measure this would take a considerable amount of work if you wanted to figure this out. Because maximum voluntary contraction varies from individual to individual. What you need to do is take a person, and let's say that they're doing a task that requires them to squeeze something, okay, or press something. You would have to measure the maximum amount of force that they are capable of pressing or squeezing or whatever the task is, and then measure the amount of force that's required to do their task. And take that force that's required over their maximum force, multiply it by 100, and you do this. That's kind of hard to do in most workplaces. It's possible, it's not impossible to do, but that's major undertaking. That's the way you determine the intensity of exertion. Hand wrist posture is, again, this qualitative evaluation. Neutral, hand wrist, noticeable deviation, clear deviation, extreme deviation. Well, what constitutes that? I haven't defined it really. You would have to operationalize that definition so that you use it consistently. Then to calculate the strain index, like I said, we have these 6 variables: intensity, duration, efforts, hand wrist, speed of work, and duration. Let's go back and look at the original chart. So, intensity of duration, this is our light, somewhat hard, and so on. These are the percent maximum voluntary contractions. And then this is the score that you get. And you differentiate between left and right because it's potentially different for left and right hand. Because oftentimes when you're doing something, let's say that we're doing work on a printed circuit board or something, you use your non-dominant hand as a vise. So if I'm right-handed, chances are I'm going to hold the thing as a they call it a bio vise, in one hand while I'm doing work with the other hand, or vice versa if I'm left-handed. Okay, so you have to score left and right separately. So you give them this rating. Then you find the duration of exertion, percent of the cycle. Okay? So if I exert this 25% or whatever duration, how much of my cycle am I exerting that maximum force? And you try to estimate that 10%, and then you get the score. Efforts per minute. How many times do I exert that maximum force? And estimate that, get a score. Hand wrist posture, we already talked about that, about estimating from very good to very bad, and you get a score accordingly. Speed, okay, I have to estimate how quickly they're working. You get one of these scores accordingly. And then the duration of tasks per day. How long do you do this in the course of a day? And less than 1, 4 to 8, and or 8 hours. And you get a score accordingly. So you have to score according to this chart each one of those 6 dimensions. And then once you get scores for each one of those 6 dimensions, and they're all on a scale of 5, and if you remember from the chart, intensity, you get 1, 3, 6, 9, 13, duration is by 0.5 up to 3, and this has no particular objective meaning. Okay? And there's a term that they use here that I think is interesting. But what you do then is you take your strain index is the multiplying. You simply multiply whatever you get for A, for B, C, D, E, and F. And the possible values, if you take all the smallest values and all the largest values, it ranges from this minuscule 0.0625 this gigantic 1,053. For most practical purposes, though, it's going to go from probably around 1 or 2 up to maybe 10 or 11. We won't actually get that full range, but you could get that full range, and this is the way they calculate their strain index levels. Again, their classification system hasn't been validated, so you would need to use that as a relative measure. This is probably, of all of them that we've looked at, is the most difficult to practically apply. And like I said, it's only distal. It gives you an idea of a spectrum, and it assesses the job at the individual worker supposedly. However, when you're talking about maximum voluntary contraction, that's highly individual dependent, so I'm questioning that. And this is the favorite thing, and this is a quote, I probably should have put this in, that it's quasi-quantitative. In other words, they put number to it just so it looks good. Okay, it doesn't mean anything, it just looks good. And we shouldn't interpret those numbers in any way. If you look back at their ratings, their scales are I think they're kind of wonky. 1, 3, 6, 9, well, maybe they're progressing by 3s, but then, whoop, 13. And here it looks like a half, a half, a half, a half, 1. And so on. I mean, they don't follow any real mathematical progression. It seems like what the authors of this did was judged how much it should add to the final total, depending on the amount of strain. And then they adjusted their categories accordingly. Questions? Okay. So, NIOSH, nauseum last week. We should have questions on psychophysical tables. We talked about quite a bit last week. We passed those. I did talk about the validation last week, didn't I? I thought I did, because it was fresh in your mind when we talked about it. Did I talk about this chart? I did. Okay. And that's that for that. One more topic to go, which why don't you come back about 10 after, and we'll do the next topic.